Hi, I'm Nick, and this is Brett, the annotation tool we used to annotate our articles. And as you can see here, there we have a bunch of articles annotated, and I will jump into this one, for example. So you can see in this article that we have a bunch of entities labeled, as well as drawing some relations between them. For example, this Walmart name is linked to this backdoor, or is a backdoor, and is linked to that by isType. Here at the top, we have Lazarus Group, and that is a threat group, and I will label that as so. So Lazarus Group is a threat group that deployed this malware, WS Link, and I will draw a relation between the two. So Lazarus Group deployed this malware. And if I go down here, the FBI linked Lazarus Group, and I will label that again as a threat group, to the $100 million theft from the cryptocurrency firm Harmony. Harmony being a organization. And Lazarus Group, a threat group, stole $100 million from that company, so I will label that as such.
Annotating in BRAT generates these .and files with all of the entities and relationships. But spaCy, what we use to train our NER and RE models, requires a JSON-L format. So for that, we use a quick script to import all of these .ann files and output something that looks like this. This is our annotations.jsonl, which is used as input to our spaCy model training. And now we are in the training environment. This is done on a Windows machine. So the first thing that we do to train the NER and RE models is to use this make command that tells it to train all the models using the GPU and transformers. So the first step that went by pretty quick there was generating all of the .spaCy files from the parsed JSON-L files. And this stage of the pipeline is training the NER model. I've sped this up. This in real time took about 50 minutes, but now it'll just write that NER model, and then it begins training the relationship extraction. This step doesn't take as long, but it still needed to be sped up. So after training NER and RE, the scores are printed out so that we could use them to evaluate our models. And then we have to upload the models that we just trained to AWS S3 so that they can be used later by the parser. So this is a sped up of me uploading the models. And there we go. The models are now available remotely to be used later.
This is the demo of the Scraper Lambda running in AWS. We have the Lambda function in the console here with the code below. I am going to go over to test, create a new test event, and we are going to execute the test, at which point the Lambda is going to run, return us a result, which we got success, and then shows a bit of a log. We'll go to CloudWatch here, which allows us to see the log streams that are coming in from the Lambda. This one right here just came in from it being executed. We scroll up to the top, you can see we start the scraper, goes through the standard scrapey console output messages, and then as it's going through, we can see that we're opening the spider, skipping articles because they're already scraped, so we're actually able to detect if an article already exists in our database and skip it. And then otherwise, we will see that any items that are not included will be written to the database at that point. And then here, if we go to Dynamo, tables, Senior Project Dynamo storage. Here we have our Dynamo databases. You can go to explore the items, and you can see that we have all of these articles showing up in the database. They're key sorted by URL. And then they also have the fields of if they've been parsed, what version of the parser was used, what time it was scraped, what version of the scraper was used, and then the text and title of the article. So that is the complete workflow with the scraper running and then placing the items into Dynamo to be consumed by the parser. Thanks for watching.
This is a demonstration of the parser. At first, there is no data within the Neo4j graph. And then we run the pipeline parser, which pulls the records from the production DynamoDB and pulls the production NER and RE models from S3. The pipeline parser will then start to pull records and parse records, as shown here. If we go back to the graph, we can see that there is the graph in the Neo4j graph, as records and data is being inputted into the graph.
After the parser finds all the information it deems relevant, it feeds that information to Neo4j, the graph database, to generate new nodes and relations if needed, or creates new relations between existing nodes inside the knowledge graph, such as so. The generated graph can then be queried and viewed in the front end.
This is our web front end for the knowledge graph. Up here, we have a search bar where you can enter a query. If I hit enter, that will return everything that matches the query that I entered. So I just told it to return everything that's in the knowledge graph, which, as you can see, we have quite a bit in there. Over here, we also have the visual query builder, which allows you to build a graph pattern that gets turned into a query. So for example, if I want to see what threat groups attacked what organizations, I can add those nodes and then add the relationship between them. And if I click OK, it will generate that query and run it. And we can see the results down here.